Yes, sir. Good afternoon, sir. Richard, sir. And then good afternoon, dear. So, today we are going to introduce our honorable resource person, Mr. P.B. Sendil Kumar, who is having the tremendous and marvelous experience in the field of information technology, as well as in the field of network and various kind of network essential and system administration. Sir is having more than 15 years of software experience as well as networking experience. Sir working different kind of academic sectors as well as industry background. He is having more than 12 years of experience in Tech Mahindra Group, and now he is working as a senior software engineer in Cisco Systems, right? So nowadays, since we are in need of that means after we are going to walk out our college, we are going to getting a job, right? How we are going to getting the job, in the sense we should have some kind of we should have some essential skill. That means how to admin the admin the system, then how to manage the network. The network is so the sorry for the inconvenience. Right. That means since we are the basic essential means how we are going to manage the network, how we are going to assemble the system, what is the system software and what is the application software. So everything that is the basic essential of our system duty. Right. In this session, Sir will teach you all those the basic essentials of network, and then what are the basic essentials of IoT. And then since I am, I request, since I am going to request you to, you have to listen the class carefully. Then how the sir will cover the entire topic. After you are going to finish your class. If you have any other doubt, kindly post the group and we will communicate. Then we will discuss. And once again, we want to give them very big applause and thanks to our resource person for his busy schedule for allocating the time for us. I request the students kindly utilize the session. So even though we are in the pandemic situation, right? So like the resource person will come over and utilize the time is very usefully and carefully. Thank you.
Thank you, sir. Thank you, sir, for giving this nice introduction, sir.
Yeah.
So now I welcome Mr. P.B. Sendil Kumar, sir, to start the session, sir.
Yeah, thank you very much, Makesh and sir. And
Yes,
hello, everyone. This is Sendil Kumar. Welcome to Network Essential and IoT session. So we will start the session. Okay. In between, if you have any doubts or any other issues regarding the devices side or other things and all, you can immediately pop up me. Okay. And then okay. Let me share my PPT. You are able to see that?
yes, sir. It is clear, sir. You can proceed, sir.
You are able to see the second screen about myself?
Yes, sir. Yes, sir. I can.
Okay.
We can able to see, sir. Yes.
Okay. Let me open
it. Can you please pin it, sir?
Yeah.
Hey, நீ pin பண்ண தனுஷ் உனக்கு வரும் பாரு எல்லாத்துக்கும் ஓபன் ஆகுது.
Yes. I'll see.
Sir name for P.B. Sendil Kumar presentation இருக்கும் பாரு அதுல pin பண்ணீங்கன்னா உங்களுக்கு வரும்.
Okay. You are able to see that about myself second PPT? Maybe I am missing.
Yes, sir. Yes, sir. Yes, sir. We can see, sir.
Okay.
Yeah.
So before starting the session, let me briefly say about me. My name is Sendil Kumar. I'm a senior engineer at Cisco and working on packet and optical networking side. And I completed Cisco certification like CCNA, CCNP, and CCIP, CCDP, and CCIE. Those certification and all I completed for Cisco side. This certification is necessary for the device managing and software engineers and all, mainly holding this certification. And I completed BTech from the MGR University, Chennai. Working in IT industry for more than 20 years. I worked various companies like IBM, AT&T, CSS Limited, Tech Mahindra. Those company and all I have worked. Now currently I am working in Cisco systems. Briefly saying about what I have worked in the company, I will tell you. In HP, I worked as a network engineer, where I have managed a DHL network. Entire worldwide, I have managed the networking devices. Next, I have worked on GTL, that is a Global TV Limited. There, I have managed Franklin Templeton Investment, that is a kind of financial banking sector in US. That network, I have managed LAN, WAN, and the entire SAN. SAN is nothing but it's a storage area network. Those things and all I have managed. After that, in IBM, I was working worldwide IBM network. I was managing, and then AT&T. In AT&T company, I was working as a senior network engineer, managing the Shell petrol networks, and then CSS Limited, where I was managing the Columbia University networks, the entire networks. It could be LAN, WAN, and then storage, cloud, those things and all I was managing. And then Tech Mahindra, I was working as a technical architect for a British telecom network. I was working in London for 1 year and managed and in BT network, we have introduced many router and switches for the BT telecom. Okay. Currently working in Cisco systems. Here I am managing that entire kind of packet and optical network devices. Anyway, over the slide, I will let you know what and all is there. Okay. I hope you are seeing this PPT, correct?
Yes, sir. Yes, sir.
Yeah.
You can see.
Yeah. So, so briefly, I have explained where I have worked and what kind of network I have managed, and how the networks are changing in the past 20 years. Okay. And what is the trend currently? What is advanced network is going on? So that and all over the session, over the PPT, I will be explaining that how that trend is changing and all. Okay, this is my industry experience. Okay, and then I will start the session for network essentials and IoT. First, I will start the network essentials. Then after that, second session, I will be covering that IoT. So agenda, I will be covering what is a networking concept, and then introduction about the networking concept, protocols, protocol layers, network interconnection and internet. I'll be covering the session 1, and session 2 I'll be covering the IoT part. Okay. Before starting the session, you tell me why do we need the network? So without network, what will happen? Can you please explain something? Anyone? What is meant by networking? Anyone can tell. What is meant by networking? Friends?
Students, sir is asking the question. Anyone can answer.
What?
Don't be silent.
Yeah.
You
A
should
few
interact.
devices connected to a small hub, sir, to share
Okay.
informations.
Okay. Is that connected with hub or it can be connected with switches, routers?
Yeah, sir, routers.
Okay. So why do we need to share the information? What is a necessary? Anyone apart from why do we need to share the information? Suppose if I am not sharing the information, what will happen? This is a very basic question. So anyone can tell. Okay. So we wanted to share the information, correct? If you want to share the information, we are using the many devices like a router, switches, as he told, that is a hub, and other latest device and all we are using to share the information. So everybody has a mobile and we are sharing many data, correct? Like we are seeing the WhatsApp data, we are seeing that class network data and other information and all we are seeing, correct? To get the data, we need a device. We need a smart device. So that's the reason we are connected each other and then sharing the information. Okay. So mainly, ultimately, we wanted to share the information or we need a data among ourselves. So that's the reason we are using those devices, and networking is essential for this, correct? And if you take that computer network or any advanced network, correct? Computer networks are everywhere, correct? If you are sitting in the car, we are connected with the GPS, correct? We are connected with WhatsApp. We are always connected with the mobile network, isn't it? Friends, you are agree that? Correct? It is impossible. It is impossible to escape them in the modern world in which we live and work. Correct? Suppose if you want to, if you are traveling somewhere, if you are going anywhere, we are always connected with the devices. So without device, it is not at all possible. So even data also following us, and we are also following the data. Correct? I hope you are agreeing that. Correct. Suppose how we are connecting. We are connecting and we are sharing the data. Connect. But we are not aware that how the data is passing from behind it also, correct? Let's say we are able to see connecting the devices. Let's say we are 3 devices or 10 devices, 100 devices. How it is connected each other behind that? Okay. How exactly it is connected? How mobile networks are connected? Why do we need to connect? Our ultimate aim is we need to get the data or we have to share the data. That's the reason it is connected. But if you see the behind that in the networking side, so many things are happening, right? Network can be defined as a group of computer and other devices connected in some ways so as to be able to exchange data. That's what he's telling, correct? We are exchanging the data. Why do we need to exchange the data? We wanted so that we are exchanging the data, correct? Each of the devices on the network can be thought of as a node. See, node means what? Our mobile also one of the node only. Computer also node, even server also node. So even if you take any other smart devices can be a node, correct? That's the reason we are connecting each other. How to connect? We need some media, correct? Using that media, we are interconnecting and they exchange the data, correct? So every device has one unique address is there. Anybody knows what is the unique address for each device? Can anyone tell me what is a unique address? Okay. Let's say I have a mobile and I have a computer and I have another mobile, correct? Let's say I have a 2 mobile and 1 computer, laptop. I have a 1 laptop, 2 mobile. Is that physically it's different, but is that logically same or not? Suppose every device has a one hardware address is that is a MAC address, correct? And using the MAC address, we are interconnecting. On top of that, IP address also it is there to interconnect the devices. Let's say I have a mobile phone that mobile phone is talking to my laptop. It's a personal hotspot. If you connect means what will happen? My mobile is connecting with my laptop, correct? How it is talking between laptop to mobile using the hardware address. You can check it out. What is a hardware address? Correct. You can talk about that MAC address also. Correct. Using the MAC address, we are talking each other. Okay. That is a way we are interconnecting and exchanging the data. Correct. And data transmission, if you go to the data transmission, why do we need to transfer the data? Correct. The data, how the data is transferred? Data is transferred through the header. Correct. In the header, all the information will be there. How the data will be packed and how the data has to go, on which side it has to go, how speed the data has to go. So everything is a data transmission, and it will take care of the header. See, that's what I mentioned here. The header contains the address of source and destination, source and destination of the computer, and the sequencing information necessary to the reassemble the message at the destination. Over the PPT, I will tell you how it is exchanging and all. Correct. But everybody knows, correct? All the data are converting into zeros and ones, binary format only. The data are transferred. Correct. I hope everybody are agreed. Correct. So that is a way, whatever the data we are exchanging, it is going by binary format. Correct. Is going that zeros and ones only, it will go. Correct. And then if you take a data networks, maybe you have seen this data network in somewhere in our life. Maybe 0.1 meter, that is it's available in the motherboard or any PCB, it is available. That is called PAN, personal area network. And 1 meter, that is a millimeter mainframe. It's used in the computer systems network. You can check it out how the data is connected, the distance, how the distance we are using to connect the network. If you take a 10 meter, in the room we are connecting 10 computers, that is called LAN. 100 meters in the building we are connecting, that is also called LAN. You can take it out the college or school example. If it is a 1 kilometer, we can call it we can call it off, that is a campus. That also we can tell about that, that is a local area network. Correct. And 100 kilometers, you can talk about, that is a countryside. It's a wide area network. 1000 kilometer, we can continental, one continent to the other continental. Let's say we are connecting between Africa to Asia continental. How we are connecting? How internet is connected? The continental to continental, 1000 kilometer, we have a wire, fiber connection wires are there. So that is connected with WAN network. And then planet, one end to other end we can connect, that also we can call it off WAN area. And then earth to moon systems, correct? That's almost 1 lakh kilometer also we can connect, that also we can call it off wide area network. Earth and artificial satellites, correct? So if you connect the internet between continental to continental, let's say India to Africa and India to US, how we are connecting the cables? Anybody have any doubt regarding that? How we are connecting between 1000 kilometers? Any idea how it is connected? Okay, I will let you know that. So if you want to connect between continental to continental, the cables are going under the sea, in the underwater, the cables are connected. That cables are called fiber link. Using the fiber link, we are connecting the cables between two countries or two continental, okay, through which we are transferring the data, correct? Let's say one cables are faulty, one cables are broken, okay, what will happen? Let's say the cables are connected with India to US, one cables are faulty. So how you will be connecting with the internet? So internet will be going down, correct? So which way you will be receiving the internet? Let's say that 1,000 kilometer the cables are faulty in the sea. How you will be connecting the internet from that other area, correct? That and all over the session I will tell you. Okay, and so mainly our internet backbone, correct? Backbone mainly connected with mesh network. Okay, to reach India or to reach other country, there will be a many path. If one path is goes down and other path automatically will take care of the networking connections. Okay, so that's the reason. Let's say for India, one connection is there between Singapore telecommunication to Airtel, and other connection between British Telecom to India. If one cable is goes down, means automatically the British Telecom cable will be take care of the data. Correct. It's a odd standby. Like one primary link is goes down, means automatically the secondary link will be coming up. Okay, through which we are getting the data. Maybe that in the slowness will be there, but you never get off that internet. You will be always seeing the internet there. Okay, so this is where we are interconnecting the internet backbone and all, correct? Okay, so as of now, do you have any doubt, friends? Friends?
Sir, what are the major difference between cloud computing and networking, sir?
Yeah, cloud computing is nothing but the centralized storage data. Okay, that is a centralized one. Okay, if you want to reach the cloud computing, we need the networking devices. That is a networking essential devices through which we are connecting that cloud computing. Okay, so cloud computing is nothing but a group of storage devices connected. Okay, let's say 100 terabyte TBs are connected in one server, correct? That how you will be reaching? How to reach that 100 terabyte of devices, correct? How to reach? We have to reach using some router and switches, connecting between two physical media, then connecting and then get the data or exchange the data. That is a one type of networking essential medias only. Okay, that storage area networking and normal networking almost similar one, but the segments are different. Okay, you got the point?
Understand, sir.
Yeah. So networking devices, you may see that is a PC. Between two PCs are connected or more than two PCs are connected, we can call to peer-to-peer. Or if you are connecting more than 100, 200, and how it is connected with printers, file servers, other storage devices are connected. So this and all interconnected means it's nothing but the networking connection devices. And mainly to connect and share the information, we are using these network devices. That is a repeaters hub, and then it's a different kind of other hub, kind of 100 base T hub, and then bridges, core group switches, router and switches. Correct. So let's say he asked one question. This is a network cloud. Cloud is nothing but the group of storage. Okay. To get the data from the network cloud, we are using these devices, correct? And then extract the data. That is a networking data. Okay. That is where we can classify it. And the network topology, may you have seen that is a bus topology, and then extended star topology, ring topology, hierarchical topology, then mesh topology. So maybe that internet is connected the mesh topology. See this mesh topology, correct? Let's say here is India is there, Here US is there. Here some other country, Russia, or here China, or European countries are means. Let's say if one link goes down, so automatically the other backup link will be come up. So that is a way the internet is connected with mesh topology and never ever goes down. That's the reason we are getting that internet data continuously on. Correct. This mesh topology is one of the successful model in the modern world. Okay. So I will be concentrated on mesh topology. Okay, rest and all it's maybe the old or somewhere they were using it in the network topology. And the network protocols, we can see that this is a source and destination. I am going the little bit deep how the data is transferring. Okay, that information I will let you know. This is a source. I am sending a source from sending a data from source to destination. It is traversing the data from source to destination like this. We can call that this is a 7 OSI layer. This this one physical layer, and then data link layer, network layer, transport layer, then application presentation session layer. All 7 layers are there. Okay. So everybody knows that this is 7 layer. Using the 7 layers only the data is transferred. Okay. So, and then how the data is transferred, I'll let you know. Before that, we'll see that what is a local area network. So local area is nothing. Local area network is nothing but it's a small area. It's connected, interconnected with the network devices is called the local area network. Using these devices, correct? So Cisco has a very high-end routers, low-end routers. Even Juniper has a high-end router, low-end router, and Huawei has a router switches. Those companies are manufacturing companies for the networking devices. Okay, they are manufacturing the switches also, and you can call some places they put it on router, and some other places they have placed that switches. I will let you know where to put a router and where to put switches and all. Okay. So over the time I will let you know that wide area network is nothing but the name itself says that it's a wide, correct? To take care of that other area networks information, we are using these devices, okay, and then exchanging the data, correct? This WAN are designed to operate over the large geographical areas, allow access over serial interfaces operating at lower speeds, provide full-time and part-time connectivity, connect devices separated over wide and even global areas. So we are using here also routers and then communication server, somewhere else modem also, but here we are not using switches. But now time router and switches are merged now, because router can be worked as a switch also and then router also. So all the functionality is merged with router and switches. So it will take care of all 7 layers. Okay. So you will get a brief idea about that over the session. I will let you know. Then this is a metropolitan area network. Metropolitan area is nothing but let's say Bangalore is connected with each other. That area, one area to other area, we are using a router and switches. Exchanging the data between the metropolitan area is called the MAN. Okay. Let's say Chennai has a metropolitan area that has a data. The data is exchanging between the MAN is called the metropolitan area network data. Okay. Here we are divided like long haul network and metropolitan area network, and then access network kind of things. Okay. Here our ultimate aim is we need to exchange the data and get the data. That is what we are doing it. Okay. Storage area networks, SANs. This is a group of hardware devices which has all the informations. This is a high-end data is stored here. That is a terabyte data will be storing here. Okay. And this using that internet, we are accessing data. Let's say the Google Cloud is there, correct? Google Cloud, and then even Nokia Cloud, okay, Yahoo Cloud. Those and all is nothing but a data. It's a bunch of data we are accessing over the internet. Correct. Let's say I am sitting here. I wanted some information from this Google Cloud, means how I will be exchanging it. So I'll be using the internet. Through the internet, I am accessing the Google data. Correct. So how the data is moving? So moving through these kind of devices, router switches, and then high-end networking essential devices. Okay. And the virtual private networks is nothing but it's a we are accessing privately. Okay. So we can set the path, like a VPN is nothing but tunnel. Okay. Let's say I am in my servers are in US. I am sitting in India. Okay, how to access that US storage? So in this use case, how you will be connecting that US storage device to India? Okay, to connect the US servers, we are using the technology that is a VPN. VPN is nothing but tunnel. Using the tunnel, you are accessing US essentials storage data. Correct. In the tunnel, other person cannot be entered. Okay, the tunnel will be always a secured one, and it is encrypted one. It is always validated from the source and destination always. Okay. Maybe you can see in that TCP handshake and all, three-way handshake and all, you have seen or you have studied, I hope. Okay, using the technology, the VPN is working. Okay, but the VPN is working over internet only. Okay, so your data will not be will not be threatened or damaged. Okay, if you are using the VPN. Correct. So this is a VPN network. Here also we are using the special devices, that is a modem. Okay, and the benefit of VPN is nothing but you don't want to any special network to connect. If you have the internet, using the internet, you can connect that anywhere of the router or switches. Okay, let's say now a time everybody are working from home. Okay, how they were working? They were connecting from the home using the VPN. Okay, so the VPN can be hardware VPN also, or it can be the software VPN also. Okay, but VPN is nothing but it's a virtual private network. It is a tunnel kind of things. After establishing the VPN, you will set the path between you and your company, or you and that storage device. So that is a need of the VPN. Correct. So this is one of the media we are accessing the data. Correct. And intranet and extranet VPN. Internet VPN is nothing but your office and you are connecting with company A, and there is a company A core is there. Let's say this head office, this branch office. This you are connecting over the internet. How you are connecting? Because using the software VPN, you are connecting. Okay. So how you are connecting means maybe over the internet, the tunnel will be formed. That is a virtual tunnel will be forming between company A to company head office. So that the tunnel will not be breakable. So once the tunnel is formed, you can transfer the data, or you are uploading or exchanging, or whatever you want to access the application, whatever you can do it. Let's say apart from my company, some other company wanted to access my company's data or storage. So that application called, or that kind of device is called, that's a extranet VPN. Okay. So there also they will give the special IP, using that they were exchanging their data. Right. Do you have any doubt as of now?
Sir, one doubt, sir.
Yeah, tell me.
Sir, if now we are using VPN, sir,
Uh-huh.
another person, some such as a company can track us. We are using VPN, hence a company can track us, sir, using the IP.
Company means see, you are using the company means exactly you tell me from the your requirement.
Sir, now I am in home, sir.
Okay.
I am just connecting with VPN and accessing a company A's website, sir. As the company can able to track my IP and find who am I, sir.
Yeah, company can track it. They have the proxy server and other security servers are there. Okay. Let's
Okay, sir.
say, yeah, using, let's say, the company is providing the IP. Okay, that IP will be always monitorable. Okay, that
Okay, sir.
IP where and all it's connected using the port, there will be find out. Let's say you are, you know, yeah, you are breaking some other network, or you are connecting some other VPN, or these kind of things. If you are doing means that is a threat, actually vulnerability. So the company
Okay,
can
sir.
track it easily. Okay,
Okay, sir.
that is possible
Sir,
actually.
can you explain about the Tor
Hmm.
browser, sir? Which
Which
is
one?
a Tor browser we are using, no, sir. It
Okay.
changes IP second by second. That like said, no, sir.
Uh-huh.
That can you explain about the Tor browser VPN processor?
Yeah, at the end of the session, I will let you know, because we
Okay.
will be covering other things and all. Let me finish all the things, networking essential and IoT and all. Let me finish it, those important topics. Okay.
Yeah,
Then
sure, sir.
we'll go that other side actually. Okay.
Yeah, okay, sir. Yes.
So the importance of the bandwidth. Bandwidth is limited by physics and technology. Bandwidth is not a free. Bandwidth requirement are growing at a rapid rate. Bandwidth is critical to network performance. Let's say we are using that in our home. What is the bandwidth of the internet things and all we are using, right? Let's say I have a 10 Mbps or 50 Mbps. So how you are calculating, correct? Similarly, we are using in our networking essential data actually. It's a bandwidth is like a pipe width. It's a small, medium, and bigger. So let's we can tell about this is a 10 Mbps, 20 Mbps, 20 Mbps, and then 50 Mbps. Like that, we can divide. If your pipe width is bigger, means your bandwidth is a bigger. That's the meaning I am telling you. And the network devices are like pumps, valves, or fittings and tapes. So like taps. Okay. Let's say where to stop the bandwidth. Okay, which way it has to go. Okay, and which direction it has to go. This much bandwidth, that and all will be using as a network devices. Packets are like a water. Okay, you take this example. Okay, you think about this is a water. Okay, how you are controlling the water, correct? So you are controlling the water through which the network devices. Let's say this is a year we called of, let's say pumps, valves, or fittings, taps. Okay, and how big is that pipe? That is a bandwidth. Okay, so this is a very layman understanding. Okay, what is a bandwidth and what is meant by the network devices, and exactly where it is used in our real time scenario, and exactly what is meant by packet. See, let's say packet, you take that this is a water. Okay, water is nothing but your data, correct? Packet is nothing but your data. So data is controlled through these valves or fittings or taps, correct? Then bandwidth is nothing but the size of the pipe. Okay, these are only one PPT is enough. What is meant by the networking, exactly where we are using, how our internet is connected, correct? I hope you are clear actually. Using this PPT, you may get more clarity on this. Okay. So I am talking about this one only mainly. These network devices are like pumps, valves, fittings, and taps. Okay. Here only the Cisco is mainly on concentrate on the devices, networking, manufacturing the devices. Okay. So this is we are seeing. And another one example like a bandwidth highway analogy we can think about. See, packets are like a vehicle. Okay. The network devices are like on ramps, traffic signals, and then signs and maps. Correct? Network devices. The bandwidth, you can think about that is a number of lanes. Okay. If you have a car, so what will happen? Car reaching in the road, how you are controlling, where to stop, how to go, or which side it has to go, which map has to follow. That and all, it's nothing but the network devices. And in the same car, if you are traveling on the single lane or double lane, or if you are going on the bigger road and all, will be is nothing but your bandwidth. Correct. This is another one example we can call it off. Okay. Now bandwidth measurement, you may have seen in your books. That's BPS, KBPS, MBPS, then GBPS, terabit per second and all will be transferred. Okay. It is a kind of equivalence. You have studied here already. I don't want to go this much deep on this. Just a overview I am giving. Then bandwidth limitation. This is a bandwidth limitation, and let's say this 10 to 100 Mbps, that is a 185 meter. 10 to 100 Mbps, the bandwidth is there, means that's maximum physical distance will be the 500 meters, and then 10 Mbps, 100 meters. The physical distance should be there. Otherwise, the data will be dropped actually. That's the maximum distance we can call it off. If you are transferring the 10 Mbps, it should be the 100 meters cable should be there. Again, it's a kind of different media is there. You can check it out. Okay. And then if it is 1 Gbps, you can make it a physical distance that has 3000 meters. Okay. Wireless can be 11 Mbps for the 100 meters. So after that, you will not get the signals. It's a kind of it's a media, how it is working. Using the layer to analyze the problem, how it is coming, what is flowing and what object flow, what rules govern flow, where does the flow occur. This over the time I will tell you. This is a OSI layer. This is a commonly IT industries are following for this. How the data is transferred from the source to destination is a physical medium. Let's say the data is transferred from here upper layer to the physical layer, and then using the physical medium, it is transferred to your destination. Correct? This is where the data is transferred. You can check it out in the OSI model, this application. Presentation session, transport, network, data link, and then physical. Okay. So this using this model only, we are transferring the data. Application, presentation, session, transport. I will let you know this one by one. If you are using the OSI model, what is the benefit? Reduce the complexity, standardize the interfaces, facilitates the model engine, ensures the interoperable technology. Everybody are in the world, everybody are following the same technology. Okay. Using this only, we are transferring the data. Okay, we will see the one by one quickly. What is meant by the physical layer? We take care of that binary transmission. It's wires, connectors, voltage, data rates. Data link layer will be taking care of your provide the connectivity and the path selection between two hosts. Here the physical address will be coming. That is a MAC address will be coming here. Okay. It will take care of no error, correction, best effort, delivery. Everything will be taken care of the direct link control, access to media. The network layer will be taking care of your provides a reliable transfer for data across media. Physical addressing, the IP address will be coming on the data link, this network layer. If it is a transport layer, end-to-end connection. Okay. Here the data transport reliability will be ensured mainly between two transport layers. Okay, here only the establish will be happening. And then after once the establish is happening, it will maintaining, and then after that it will determine how to terminate, when to terminate. Okay, here only the virtual circuit will be happening between the two devices. Fault detection and the recovery information flow and all here is started. Session is nothing but you are opening the multiple sessions on your window. One browser you are opening, and parallelly you are opening another one browser, that session will be taking care of this layer. Okay. And then presentation is nothing but your ensure data is readable by receiving systems. Let's say the other end people are not able to read your data, means immediately the error will be coming using the presentation layer. Application layer is nothing but you are seeing, correct? Now I am presenting, correct? That you are seeing, no? That is called the application. That application only will be going through the presentation session, transport, network, data link layer, and physical layer. How it is going using the header? It will split it. It will split and then send across the internet. Okay. And this is a way it is going. Let's say the source and destination, peer-to-peer communication is happening between destination to source. And then here is a host and a host B. Let's say I am sitting in Bangalore and you are sitting in your college. Okay, how the data is transferring here? This is an example actually. Let's say I am a host A and you are a host B. I am sharing my presentation. Okay, this is application Google Meet, correct? I am presenting many things that will be converted into, it will pack in the packet. Okay, put it in the session. Again, it will be sending into the transport, that is a TCP UDP transport layer. And then via the network media is nothing but it will be reach your router and switches nearby. So after that data link layer, that is switches. So finally it will take care of the physical media, that is a zeros and ones will be going here. So this is a model. Yeah, now you see that this encapsulation is happening here. Let's say data is application presentation session, all are in the data that will be encapsulated in that transport layer. After that it is going to network, then finally it will set the frame header. Okay, once the frame header is forming, then it will convert it into zeros and ones, and finally it will transfer that by router and switches. Okay, so this is an example data at the each layer. Let's say this person is sending an email. While sending the email, how the data is that your packet is split. This is the way it is split. Email is nothing but data, or you can call it off, that is the packet. Okay, and then in that network header, it will comes inside whatever the email. On top of the email, that is called data, the left and right hand side, the one header will be forming, correct? That header is called the packet, entire packet. The frame header, network header, the data, frame trailer, then entering into your router. The router will be reaching the internet. So this is a way your data is transferring, or whatever the application are accessing the network, exchanging the data, everything is comes on like this only. Right? This is a hierarchical network design. Maybe this is an important one. Maybe you are, I hope you are understanding this. This is a kind of how you are exchanging the data. Okay. Every data is, added the frame. Okay. That frame will be converted into zeros and ones. That zeros and ones only will be sending on the internet. These are very basic network terms. Okay. If you have any doubt, let me know. Okay. How the data is transferred. This is an essential one for everyone. Okay. This hierarchical network design. Okay. If you take in the world, this is a hierarchical design is working. We are sitting in home or office, that is connected with switches. That switches connected with that nearby routers. That router is connected with the layer of the core layer. That core layer is connected with high-end router. That high-end router is connected with the internet. This is where we are exchanging the data. But we are not aware that what is happening behind that. We may see the data, but how the data is going and flowing, this is a model actually. So this model we called off this hierarchical network design. We can think about this core layer, distribution layer, and access layer. So everybody are accessing, so that is access layer. Okay, your access layer will be distributed to core layer will be distributed to internet. Okay, this is a way that your data is traveling one side to other side. Okay, any doubt, let me know. And as of now, we have seen what is meant by data, why do we need to exchange, and exactly how that your packet or data is controlled, and then what is a bandwidth, correct, and exactly how data is managed by some other network devices, correct. So as of now, I have explained this, and we will see that how the use case is happening in packet travels, how packet travels in network. We will see in a small YouTube video. In the video, you can check it out. Let me open it.
Will your child win free education for life? Book a free coding class. The amazing journey.
You are able to see my desktop, correct? Friends, you are able to see?
No, sir. No, sir.
Not able to see. 1 second. Maybe let me check it out. What is the issue there? Resume your presentation. Okay, stop. You are seeing now?
Of data packets from a data center to your device forms the back.
No, sir. No, sir. It's not
It's
coming.
not coming. 1 second. Options. Full screen. Let me share my screen.
Sir, go to your Chrome tab and you can open it, sir.
Okay.
The amazing journey.
You are able to see?
No, sir. It's not coming.
Not coming. Yeah. Let me
Yes.
presenting mode also. 1 second. Let me present it. Change the layout. Options. 1 second. One second. Let me share again. I am presenting only.
Phone of the internet. This data flow is governed to make the most efficient transfer of the data. It is apparent from this animation that this governing of the data from the source to the destination through such a complicated network is not an easy task. This whole process of the efficient flow of data from the source to its destination is known as routing. Let's try to understand routing through an analogy. Imagine a scenario where you are trying to reach your home from your office.
Have you thought about learning data science? You know, you should take this online data science course on Udemy. It's taught by an expert instructor. You'll learn machine learning with
The video is not coming, sir.
Video, okay.
It's the audio.
Audio only coming, okay.
Yes, sir.
It's $15.
You are presenting, second. Turn on. I'm presenting only. Maybe some browser issue. Let me open another browser.
Yes, sir.
You are seeing this browser, that Google Chrome?
No, sir.
Okay.
No.
1 second. Okay, stop sharing. Let me work on. You are presenting, okay. Video. Firefox cannot allow permanent access on your screen. Okay.
Better you can copy that YouTube video in the chat box, sir. Paste it in the chat box. I can able to share.
Yeah. Yes. Yeah. That also good actually. Which name is that? I have to. This information technology.
Yes, sir. Yes, sir.
Okay. I will send to everyone.
Yes, sir.
Okay. Yeah, you can operate it. You can share. So here we will see how the data is transferred. Sir, you are sharing that?
Yes, sir. I am sharing.
Yeah, please.
The amazing journey of data packets from a data center to your device forms the backbone of the internet. This data flow is governed to make the most efficient transfer of the data. It is apparent from this animation that this governing of the data from the source to the destination through such a complicated network is not an easy task. This whole process of the efficient flow of data from the source to its destination is known as routing. Let's try to understand routing through an analogy. Imagine a scenario where you are trying to reach your home from your office. The roads are full of traffic. In this scenario, you look up the road and traffic conditions on Google Maps. Based on the traffic situation and the road conditions, you take the easiest path to reach your home. Similarly, in routing, the decisions regarding the movements of packets are taken based on the state of network, and a device called a router makes these logical data decisions. The main purpose of having a router setup is to find the most efficient path through which the packets can be transferred from source to destination. Using very sophisticated algorithms, the router makes the decision as to which router or device the current packet has to be sent via. This procedure is repeated until the packet finally arrives at the destination. Routing can be divided into two categories, static and dynamic. In static routing, all the routes are set in a router manually. Thus, if there is any change in the network, there will not be any change in the route, unless someone manually corrects it. In dynamic routing, routes are set by the software according to the current state of the network. Network changes, such as link failures, traffic changes, and cost changes, will be updated at every discrete time step, and, based on this information, new routes will be decided at each time step. Dynamic routing is preferred over static routing because the routers update themselves according to any changes in the network. Let's learn about one of the most popular dynamic routing algorithms, the link state algorithm. The link state algorithm has two parts, reliable flooding and Dijkstra's shortest path algorithm. First, let us understand the Dijkstra's shortest path algorithm, an algorithm developed by the famous Dutch computer scientist Edgar W. Dijkstra in the year 1956. Consider this network. Here, the costs between each node are marked. The challenge is to find out the shortest path from one node to another. The Dijkstra algorithm produces a table as its output, and using that, we can determine the shortest path in a network. This table is generated for the vertex A, and using this table, you can predict the shortest path to any other point. If you want the shortest path to point I, just check the previous vertex. From this vertex, check its previous vertex, and on until you reach point A. This table is generated using an iterative method, with the initial values of the shortest distance as infinity. Due to a shortage of time, we are just animating the procedure used to generate this algorithm. After the end of the iteration, we get the routing table, the output. Now we look at the first part in a link state algorithm, reliable flooding. You might have noted that to perfectly execute Dijkstra's algorithm, each router should have the information of the entire topology. This is the first step in link state routing. The neighborhood information of a router is known as its link state. This information can be the IP address of the neighboring router, cost of the neighboring links, health of the links, etc. The small packets that contain this neighbor information are known as link state packets. As mentioned in the name, we should accurately flood each router with the link states of all the other routers in the topology. This is very similar to how gossip in a classroom spreads like wildfire from one student to another, until everyone knows it. In a network, initially each router knows its own link state. For this small network, A passes its link state packet to its neighbors, B passes the packet to its neighbors, and so on. In this way, all the nodes will have the complete link state information of the topology. With this packet information, all nodes create or update a routing table and apply a Dijkstra shortest path algorithm to send the packet. However, flooding is not so simple. Consider a scenario where three nodes, A, B, and C, are interconnected. Node A sends link state information to B and C. Similarly, C sends the information to B, and B sends information to C again, and the process continues in a loop. This issue is known as looping. So, in an ideal scenario, you would want the node to receive this information only once. So, how do you overcome the looping problem? Each packet is assigned a unique ID. When B receives this packet with its unique ID from A and C, it does not send it to C. After the flooding operation, each node independently runs Dijkstra's shortest path algorithm to determine the shortest path from itself to other nodes in the network. The algorithm we saw is implemented in a network with the help of protocols. Applying the flooding operation to the entire global network is an almost impossible task. The protocol of the link state routing algorithm is known as OSPF. In OSPF, the complete network is divided into several local areas. A backbone area is also created, which shares at least one router from the local areas. This way, a few border routers are created. You can see all the local areas are connected to the backbone area via these border routers. In OSPF, the flooding operation happens within a local area, not globally. If the packets of a local area need to travel to another local area, they have to go through the backbone area. This is clearly illustrated in this animation. If the data packets have to flow from area 2 to area 3, they have to pass through the backbone area, not directly. This type of structure reduces the complexity of the operation by reducing the size of the routing table and also helps in the scalability of the network. We hope this video has given you a good overview about the routing operation. Thank you.
Hi friends, I hope you got that maximum of the information on how the data is transferred, and maybe you have seen the data, how the data is transferred from one area to other area, and what kind of devices they were using to transfer the data, right? You may understand about that internet also, how the internet, this is actually, if you understand these things, you may understood about that internet also. Okay, so this is a way we can transfer the data. Okay, let me share my screen again. Share, cannot share your screen. You have seen my screen?
No, sir. No, sir.
Okay. Some message is coming. Okay, okay. 1 second. Let me log out and then log in for Firefox.
Yes, sir. So students, if you have any doubts, you can ask to sir. Okay, sir will come within 5 minutes. There is some technical problem in his laptop. If you have any doubts, you can ask to sir.
Sir, that Tor VPN processor.
No, sir, work on it.
Okay, sir. Okay.
So what about 43 members தான் இருக்கீங்க? ஏன் லெஃப்ட் ஆயிட்டே இருக்கீங்க எல்லாருமே? உங்களுக்கான வெபினார் தானே நம்ம அரேஞ்ச் பண்ணிட்டு இருக்கோம். யூடியூப் லைவ்ல ஓடிட்டு இருக்கு. எத்தனை பேர் அதை பாக்குறீங்கன்னு எனக்கு தெரியல. நம்ம டிபார்ட்மெண்ட்டை நம்ம அடுத்த லெவல் கொண்டு போறதுக்கு தானே we are planning. Voice not coming, sir.
Can you hear me?
Yeah, yes, sir. Yes, sir.
Yeah. Now you are able to see?
Yeah, yes, sir. Yeah, yes, sir.
Okay.
Sir, you can proceed.
Yeah. So, so as of now, we have seen that how the data is transferred, how the data is connected with that devices, okay, how the internet is connected, what kind of media we have used, and what is the bandwidth. So everything we have seen, okay. And do you have any question here before
Sir,
going to IoT?
I
Yeah.
mean, Tor browser VPN processor.
Yeah, that we will see. We will see that after getting time also for the, because we need to cover the emerging technology for IoT. Okay.
Okay,
Okay.
sir. Okay, sir.
We will cover the IoT first. Okay, that is a kind of emerging technology for the current system. Okay.
Yeah, sure, sir.
Then we will see that. Anything apart from this session, you have anything that apart from your doubt? Anything doubt on networking devices, how the data is transferred?
We are clear, sir.
You are clear, correct? Okay,
Yes,
you
sir.
understood the OSI layer and all, correct?
Yes, sir.
Okay. So we will go to the IoT. Okay. So this is emerging technology. Okay, maybe you will be working after a year also, after 10 years or 50 years, or it will be there always. This emerging technology one. Okay. So any idea what is IoT? Anyone? What is meant by IoT? Why do we need IoT?
Sir, some machines are
Internet
connected
of
through
Things.
internet through IoT, sir.
Okay. Come again.
Such as devices like Arduino,
Uh-huh.
these things and all programmed and used for IoT purposes, sir.
Okay. Suppose what will happen if I am not connecting with IoT?
Uh, Through IoT, we can get accurate result at fast, sir. Fast in time interval, we will get the output, sir. Or
Okay.
else we want to go to the machine and see what will be the output. These things and all we want to study, sir. And also, if in case of any issue in the machine, the IoT device will assure us, sir. It will send a message that the device is crossed over 40 degrees Celsius. That things it will through IoT we get that messages and all, sir.
Okay.
So,
Okay. Actually, your answer is okay. What is your good name?
Danush Kodi, sir.
Danish Kodi. Okay.
Yes, sir.
See. The thing is, let's say, so what and all is emerging technology in our computer science or IT? What is emerging technology? Did you see somewhere else?
IoT
See,
things and all.
IoT is one of the emerging technology. What else? Suppose let's say if you are knowing about the emerging technology, so you will be getting a job, correct? So what kind of technologies are there
Machine
in that
learning.
machine learning? Okay.
Yes, sir. And
Then
these,
data science.
these things and all, sir. AI, artificial intelligence.
Okay.
These things and all come under this category, sir.
Okay.
Yes, sir.
Fine. Did you see the data analyticals, data science?
Yeah, sir, but not so accurately, sir.
Not okay. Data science. See, emerging technologies are nothing but we have to work now. There is a emerging to finish the work. Correct. Let's say artificial AI. AI is there now. It has been there past 15, 20 years. Correct. Why do you need suddenly the AI? Any idea? Anyway, I'll let you know that also. So emerging technology is nothing but the technology is growing now. Correct. Let's say IoT, it's growing. So around in the world, 40 billion devices are connected each other. How much? 40 billion. So those devices are need to be smarter. Okay. To enable those devices, we need IoT platform. Okay. Let's say in our home we have a fridge, TV, and other AC, doors. So that and all some non-technical devices. So how to merge those devices, correct? Let's say you can layman tag, we can talk about you need to talk to those devices in smarter way. That is called IoT. Okay. Let's say you wanted to talk to your fridge, you wanted to talk to your AC, you wanted to talk to your door, okay, you wanted to talk to your car. So how will you talk? So how to talk, when to talk, correct? So to enable the smarter, to enable that smarter things on the devices can be anything, okay, that's called IoT, Internet of Things, correct? So we will see that what is IoT, how it works, okay. In Ajanta, what is the Internet of Things? We will see. Why do you need Internet of Things? Benefit of IoT, IoT features we can see. Okay. This is emerging technology. Okay. Maybe the networking, whatever we have seen the previous session, I don't think so. That is emerging technology. But that is a mature technology. But this is emerging technology. Okay. If you study well, let's say if you know the IoT with the Python programming, if you know the coding knowledge, you definitely will get a job. Okay, because of this is a emerging technology. Okay. On top of that, if you know artificial intelligence with the coding knowledge, you will get a job. Okay. And if you know the data science and the coding knowledge, you will get a job. Okay. If you know the machine learning plus any Java or any other artificial, this one Python, Ruby, those kind of programming knowledge, if you know, you will get a job because those are all emerging technology. The emerging technology has the capacity, okay, capacity in the sense, you know, what is the business capacity? Almost 800 billion revenue are there. 800 billion, 800 or 900 billion revenues are there. Okay, let's say TCS, let's say Infosys, let's say Cisco. Other top MNC companies are working on this emerging technology. Okay, in among the emerging technology, this IoT is one. IoT is nothing but you are just enabling the smarter devices. Okay, that's IoT. Okay, let's say what is Internet of Things. You will see that in our home, if you take, you wanted to take about this door, AC, light, smarter way you wanted to switch off, or you wanted to switch off from your office, you wanted to switch off from your college. How to switch off? Okay, you wanted to switch on the AC or switch off the AC without going to physical switch off. How to switch off? Or you wanted to open the door. Let's say you are going to your home. Assume that you are reaching your home by 2 minutes, but by the time your door has to open. So how to open? Now time everybody are smarter, correct? Everybody are behaving a smarter way, correct? Let's say I don't want to open my using the key. They don't want to touch the physical media. So that's the reason what happening now. Everybody are having the mobile phone and then application using that they were operating these things. That's IoT. Okay, and I have a car. Okay, in the car I wanted to control. Let's say if my car is going behind a 55 kilometer per hour, I don't want to go. I wanted alarm notification. So I have to enable the IoT so that it will intimate. Okay, and I wanted to switch on the car from my home or from anywhere. Then I will be earning that. It's possible now time. So this is nothing but it's a very very general knowledge connecting everyday things embedded with the electronics, software and sensor to the internet, enabling them to collect and exchange the data. Here also exchange the data, nothing else. Okay. So how to talk with each other. Okay. Using that IoT medium, IoT platform, you are enabling. If you are enabling this kind of things, the devices will be smarter. Okay, let's say, why do you need IoT? Okay, one patient is there. Okay, if you are enabling this person in IoT platform, Okay, machine itself is managing this patient. Let's say what is a oxygen level, what is that this one, all kind of other kind of breathing level. Okay, how is body temperature, correct? So everything, if you are putting in one of the storage or in the data, okay, automatically it will monitoring you, like a IoT continuously monitoring your health. Okay, using that data you are controlling, or your hospital can be controlled that data. Okay, let's say here I am telling about that patient. You can take it about car, you can take it about any home appliance. So whatever you want, you can take it out. Okay, and then enable the smarter way, and then monitor that, exchange the data. Okay, that is the way it is going. Again, why do we need IoT? Again, I will explain it. This is before ambulance arrives, all of the facilities are ready for the patient before on reports. So let's say one patient is coming. So how hospital will be knowing this person is coming, and what is his oxygen level, what is his his pulse level, and all, how we will come to know. Okay, using the IoT you will get it out. Okay, we will see that one by one. Okay, let's say you are giving a prescription and medicines and operation theater datas, everything they will put it on IoT platform. That IoT platform we can enabling and then exchanging the data. Okay, that is why we are monitoring it. Okay, and then let's say if you go in deep, expanding the dependence and then of humans, let's say uh, interact, contribute, collaborate of things. Okay, this is just I am telling you. I am taking a one example, but you can take a AC or you can take a car. How to make that things as a smarter is nothing but IoT. Okay, let's say I have a car. I wanted to talk to car, but I don't want to talk physically. My application has to talk. That time, what will you do? So your car has to talk to application. Okay, my mobile has to talk to the same application. So using that interface, you are controlling that car's things, correct? That to enable that smarter way, it's called IoT. Okay, the benefit of the IoT is efficient resource utilization and minimizing human effort, saves time. So this is a benefit of IoT, correct? Dhanush Kodi told, correct, like save times, minimizing the human effort, efficient resource utilization. Okay, this is the things we are IoT is enabled. Let's say by 2022, almost 40 billion devices are to be connected in IoT. How to connect? Using this IoT only, correct? Let's say the trains are there in the Indian Railway, has many trains are there that has to be enabled IoT. How to enable that use case? You take that use case. Indian Railway has to connect with IoT. What to do? Now everything is all the trains are manual operating, correct? So how to enable the IoT? How to enable that IR as a smarter way? Think about that. So that is where that IoT will be started. Okay. The
Sir,
IoT.
some applications of IoT.
Sorry.
Some applications of IoT.
Exactly. So think about that use case. Okay, how to enable the IoT on the Indian Railway? That is a use case, correct? How to enable? Now everybody are operating manual, correct? So let's say the gate is there, train that railway station is there, that is operated by manual, correct? Isn't it? Let's say how to make it that is automate. How to make? Just tell me, just one hour. Sorry. Yeah, then
Yes, sir.
so let's say I'm telling one use case. Let's say Indian Railway has to enable by IoT. What to do? correct? So that railway, whatever the train is coming, correct? The train has some sensor, correct? If that train is coming 2 kilometers before, automatically the sensor has to detect the application. That application has to enable the gate, correct? Isn't it? Enable the gate in the sense, let's say my gate has a one sensor and the Indian Railway has a one sensor, that train has one sensor. Both the sensors are talking on the IoT medium. That is you can talk about, that is a one centralized application. Using that application, automatically the gate will be open or close. Let's say the train is going, that it's passing that gate. After that, the gate has to open. How to open that? It has to detect train is passed, so that gate has to open. So that is this is one of the use case I am telling. So this is a way we can enable the things. We can enable the things on the smarter way. Okay, then we can reduce the minimizing or reducing the human effort. Correct? Automatically that things will be working. Okay, and then efficient resource utilization. We can use that resources very efficiently. And then we can save the time also. That's a benefit of IoT. Okay. IoT features nothing but connect, analyze, and then integrate. Okay. You want to connect with the device, connect the various things to the IoT platform, analyze the data collected and use it to build the business intelligence. Okay. Integrate is nothing but integrate the various models of improve user experience. Okay, today you are developing something and tomorrow it is to be developed, to be modified, means you can modify. Okay, so that is a way we can take about. Let's say Indian Railway has to be enable IoT. Think about that use case. Okay, let's say the government bus stop is there, that has to be enabled the IoT. How to enable that IoT? And the government buses are arriving, how it is departuring time and all, you can enable in IoT. That is also possible. This and all is future generating technologies. Let's say if you are using the IoT, you can enable in many sector. We can enable the IoT. Let's say Indian Railway, Indian government offices. Okay, we can enable in your college also. You can enable the IoT. Correct. You can enable it many things. You can think about. Correct. So that is a way you can. The IoT is nothing but you are making devices to be smarter. Nothing else. Buy some Raspberry Pi. This is a device. Okay, you think about, you just do the Google. Okay, buy that Raspberry Pi. Okay, and then search in the Google how to use that, how to enable the things on a smarter way. Okay, you can follow this URL also. Okay, and then fix it on any media or any things, you can fix it, and then you can talk with each other. Okay, so this is a way we are making things on smarter. Okay, you can buy, you are a computer science and IT student, no? So you can buy Raspberry Pi and do some googling and then make any one of the things for the smarter way. Okay, this is way we can make it IoT. Okay, if you make a one use case, then other use case and all very easy to make it. Okay, and then I have some video for this use case. Okay, you can see this use case on that YouTube. Okay, and then see how they were modified. Okay, before going that, do you have any doubt on IoT? Friends, you have a doubt on IoT, or you can ping me also, or you can, I will send you my email address. Okay, if you want to do some project, let me know. Okay, so before that, you have to buy a Raspberry and do R&D. How Raspberry Pi is there, how IoT to be enabled on other devices. You do it, get the knowledge. Okay, before starting, you need to know how the Python coding. Okay, and then you let me know. I can give you a project also. Let's say in our home we have a door. That door has to be open automatically. Okay, this is a project. Okay, I'll give some other project also if you are interested. Okay, before coming, you just study and come. Okay, we have so many projects are there. Like this, you can do it. Friends, you have any doubt on IoT? Overview I gave. Okay, what is meant by IoT? Okay, how it is connected and where to connect. Okay, now time even you can track this COVID patient also through IoT. Okay, using the sensor, you can track the COVID-19 patient also. Okay, let's say 2 COVID-19 patients are there. If that person is coming, they were violating more than 2 meter, that time you will get a signaling or notification. That is also possible. Okay, those things and all we can do it on IoT side. Okay, this is where it is going. You have any doubt on IoT? Friends, you have any doubt? So how to start, how to buy the Raspberry Pi, or what kind of project you have to do, or why do you need this is emerging technology? Do you have anything? Or do you have any doubt?
Sir, no, sir, you can proceed, sir.
Yeah.
I think, yeah.
Okay. Then I will show you on YouTube one use case. One use case I will show you how the IoT is enabled. You are seeing my desktop? You are able to see my desktop?
So, no,
Once
sir,
you
your
are able
PPT is coming. Your PPT is coming, sir. Not.
Okay, maybe I will ping you that URL. You can show that.
Yeah, sure.
Maybe some other permission is there. That's I am not getting. I will ping you that. One second, I will share. Exit full screen. I will ping you that URL. Okay, you can just run it.
Yes, sir. Yes, sir.
Yeah, you can just show that you can just see this is an example of the IoT. Okay.
The Internet of Things promises huge new opportunities in business and society. In this video, we show how by connecting things like wearables, smartphones, cloud software and physical sensors using Fujitsu's Run My Process, we can have a huge impact on the quality of care received by a critically injured cyclist. A cyclist has had an accident and sustained a serious head injury. Treatment is required as quickly as possible. Let's see what might happen today. It is several minutes until a car passes and the driver calls for an ambulance. The ambulance is dispatched. Due to unclear location information from the caller, the ambulance cannot find the location of the incident, wasting precious minutes. Paramedics stabilize the patient and the ambulance starts the journey back to the hospital. The paramedics do as much work on the patient as possible without access to medical records. With time of the essence, the ambulance gets caught up in a traffic jam, causing delays and losing valuable time. After finally arriving at the hospital, paramedics discover that there are no staff available. The patient has to remain on a trolley until doctors become free, losing even more time. In this scenario, with all of the delays and lack of information, the outlook for the patient is not good. Fujitsu, our vision is for a human-centric intelligent society. What does this mean, and how could it have helped this cyclist? By combining the connectivity of the web with the power of cloud computing, we can integrate infrastructure, information, and people to deliver human-centric systems. In this scenario, Fujitsu Run My Process is used to integrate sensors, information systems, and people in order to transform the end-to-end emergency response. HOP Ubiquitous provides Bluetooth smart sensors with IP version 6, COAP, and OMA capabilities. These sensors collect a combination of acceleration, cycling cadence, and heart rate data from both the cyclist and the bicycle. The cyclist's smartwatch correlates this data and detects that a serious accident has taken place. In a split second, it uploads it, along with GPS location and the cyclist's key medical information, to the Fujitsu Run My Process cloud platform. The platform first raises an alert to the 112 service using the recent EENA standard for emergency services. The control center recognizes the severity of the incident and dispatches the closest ambulance. Next, the platform verifies live traffic status using sensor data from the Smart City Operations Center and calculates the quickest route to the accident. The cyclist's location and the optimum route calculated using traffic data are pushed to the ambulance. The estimated time of arrival for the ambulance is sent back to the smartwatch. Immediate notification of the accident coupled with a precise location and optimum routing means that the ambulance reaches the cyclist several minutes earlier. The ambulance heads towards the hospital. Using the recent EPSOS standard, the platform requests the cyclist's medical records from the hospital and pushes them, along with the accident information from the sensors, to the paramedic in the ambulance. Through connectivity, the paramedic is able to optimize treatment en route, while also keeping the hospital updated in preparation for arrival. With every second counting, traffic congestion suddenly breaks out ahead of them. But before they hit it, the Smart City Operations Center notifies the Fujitsu Run My Process platform. The platform in turn contacts the 112 service and finds the best alternative hospital with available staff. This hospital is further away, but it is now the quickest route to treatment. When the team arrives, staff know the full extent of the cyclist's injuries and his medical history, and they spring into action. These technologies are not futuristic, they exist today, but it is through connecting them together that vital minutes can be saved, and the life of the cyclist. Human-centric innovation connects people, information, and infrastructure. With this approach, we can build a better place to live and a better place to conduct our business. A human-centric, intelligent society.
Hi, can you hear me?
Yes, sir. Yes, sir. You can proceed.
So I hope you have seen that use case of that IoT, correct? So here how that human is saved if you are enabling the IoT, correct? If you are not enabling, so what will happen? So that is a use case. Okay. In that video, you have seen all the smarter devices are connected, and even he was using that smarter watches or something. So using that, he got all the information in the hospital, correct? So that using that information, the doctor get the quick data, and then other things and all he got it, so that it is rectified quickly, correct? That is a use case. Here the session in a minute, you can see that we have seen also like what is IoT, why IoT is there, benefit of IoT, and the features of IoT. And I told you to buy a Raspberry Pi installation, how to enable the Raspberry Pi. And then we have seen that use case, how that IoT is enabled on the one accident case, correct? So this is a way in future also, after even 10 year also, all the things are connected with IoT. It will be connected, it has to connect. Yes, we have more than 40 billion devices to be connected. So that's the reason that the device also will be smarter. So here the vacancies or job opportunities are there in the IoT side, correct? To enable those devices. Okay. So till now we have seen all kind of IoT smarter details and all. You have any doubt on that as of now? Or I completed my session. What is a data network and IoT? I have completed. Okay. You have any question and answer or anything you have a doubt in your mind? You can please ask me now also. I hope you got all the details. Okay. I hope you have enjoyed that session. Correct.
Yes, sir. We had enjoyed the session so much, sir, and it's very nice.
Yeah. Thank you.
Thank you so much, sir. Thank you so much for
Thanks
coming
a lot.
to. Yes,
Yeah.
sir.
Yeah, and one student has asked like what is meant by that other browser or things and all. His name is Dhanush, correct? Okay.
Yes, sir. Yes, sir. He's from second year IT.
Okay, he's from second year. Okay. Anyway, you can tell him my number also. This is my Gmail.
Okay.
Tell him to send a mail.
Okay, sir.
Then I'll just reply that.
Yes, sure.
Okay. He's there or he's just left?
I think he is the Dhanush Kodi. I think he left the meeting. There is some technical issues. He's left the meeting. So no issues, sir. Yeah.
Okay. This is my email address. You can tell him to contact. Okay.
Yeah, sure. Sure. Yes. Sir.
Okay. Sir, anything else, sir, to be discussed here?
No, sir. No, sir.
I hope you have enjoyed the
Any
session.
doubts you can ask for 5 minutes.
Yeah.
We'll give 5 minutes time, and if you have any doubts, you can ask first.
Yeah. Friends, you can ask.
Students, you can unmute it and you can ask the doubts to sir, so that he can able to answer. If you have any doubts, be frank, and it should be an interaction. Okay. So if you learn, this is a learning purpose. This webinar is a learning purpose, and you have to know most of the things. Actually, Sarah has covered a lot from network and to IoT. So if you have any doubts, you can ask or tell your feedback. Unmute it and talk.
Yes.
Krishnamurthy Nagarajan from final years. You can ask questions. from third year, second year IT.
Okay, no doubts. I think
they're not having any doubts.
yeah, no doubts. They are telling. No problem. I have sent a mail details.
Yeah, sure.
Okay.
Right, sir. So if you have any doubts regarding that, you can ask to sir through email. Actually, send the email in the chat box.
Yeah.
So that you can able to see. And once again, thank you so much, sir. I'm proceeding my vote of thanks.
Yeah,
on
sir.
behalf of the management of chairman sir, secretary sir, and trustee ma'am, and my beloved principal ma'am, and our most respected HOD sir, and my faculty members.
Okay.
So thank you so much, Sandil Kumar sir, for giving such a nice presentation about network essentials and IoT. And it should be a valuable session for our students or for our IT students to engage and to enlarge their skills and careers in their future technologies, and they can. It should be very useful for their projects also. And if you're free, you can come to the college after this COVID-19, or you can come and directly present to the students, so that it's very useful for us.
Yeah,
thank you so much, sir.
Yes. Yeah, definitely. Your good name, sir?
Richard Williams, sir, from IT department, sir.
Okay, voice was breaking. What is your good name?
Richard Williams from IT department. Yes, sir.
Fine, Richard.
Yeah.
Fine, sir. Yeah. I will. If that time is permitting, definitely I will come up with some of the devices. Okay.
Yeah.
Or sure. I will show you the demo directly. Okay.
Yeah.
Then definitely our student can access that devices, or they may get the knowledge more. Correct.
So on behalf of our IT department team and our students, I want to congratulate and I want to thank you so much, sir, for coming and giving such a nice session to our students. Thank you, sir.
Thank you, sir.
Thank you, students.
Yeah. Thank you, friends. Yeah. Thank you, sir.
Yes, sir. Thank you so much.
Thank you.